Hello everybody, Root Beer here with another question from the year 2001 Fermat contest, one of the math contests put out by the University of Waterloo. And we're up to question number 20, which is the last question in part B, and the last question to be worth 6 marks. So we're going to do question 20 in this video, and then in the next video we're going to start question 21, and that's in part C, where the questions are harder, but they're worth more marks, specifically 8 marks in total. Okay? So, on with question number 20. Alright, so point P is on the line y equals 5x plus 3. The coordinates of point Q are 3, negative 2. Are those on this... Now it doesn't look like Q is on the line, just substituting 3 in here, we should get 18. Okay. If the midpoint of if M is the midpoint of PQ, then M must lie on the line. Okay. Interesting. So we don't know exactly what point P is. We're not given any of the actual values that will let us determine point P. So we're going to have to sort of give point P a very generic term. So we're going to say, let point P have x-coordinate x naught and or a or something like that. So I'm going to say So I don't know what it is, so I'm going to give it the name little p. Now I can determine its y-coordinate in terms of its x-coordinate, because I know it lies on this given line, 5x plus 3. So I know that the y-coordinate is 5p plus 3. So p is at p, 5p plus 3. Okay. So now, if I want to determine the coordinates of the midpoint between P and Q, all I have to do is average the coordinates of P and Q. So to find the x-coordinate of M, I average the x-coordinate of P and Q. Well, P has x-coordinate of P, and Q has x-coordinate of 3, so I would average them. P plus 3 over 2. And then to get the y-coordinate, again, I average. So 5p plus 3, that's the y-coordinate for P, plus negative 2 is the y-coordinate for M, and we average them. We'll just double check. Yes, it is minus 2 here. Okay. So can I simplify these? Well, the minus 3 and the 3 and the minus 2, yeah, I can simplify that a little bit. So p plus 3 over 2 and 5p plus 1 over 2. So M generally looks like this, and this will trace out a line. All right, if we imagine our little picture here, M is somewhere down here, Q is somewhere down here, and our line passes this, so 3 is there. We started going up like this. So we have a lot of different possible locations for P, an infinite number of them. So the midpoints are all going to lie on a line. We just need to figure out what that line is. And it's represented by this relationship right here, but we need to get this line into the form y equals mx plus b, the usual form of the line that we know from, I learned it in 9th grade, but I don't know where it is in the curriculum these days. They change it, and it's probably different depending on where you live. But I know I want it to look like y equals mx plus b. Okay? So, what can we do here? Well, if I want to figure out what b is, that's going to be the y-intercept. And that's going to occur when x is equal to 0. So when is p plus 3 over 2 equal to 0? That's going to give us what the y-intercept is. And that occurs when p is equal to -3. We could rearrange this equation. You'll get p plus 3 equals 0 by multiplying both sides by 2. And then you bring the 3 onto the other side. P equals -3. So that means b is 5p plus 1 over 2, which is 5 times -3 plus 1 over 2, which is -14 over 2, which is -7. So already I'm looking for something with an x-intercept of -7. Well, E is my only option here. E is my only option. So the answer should be E, but I'm just going to do a little bit of completion. I want to figure out what M is as well, because maybe we didn't try to get the B coordinate first. Maybe we tried to get our slope M. So if I want the slope M, well, slope is rise over run. What I could do is I could figure out two different midpoints and do rise over run with them. So if P is 1, we're going to get 4 over 2 and 5 plus 1 over 2. So that's going to be 2, 3. So 2, 3 is on our midpoint line. And if we let P equal -1, we'll have 2 over 2 and -5 plus 1 over 2. So that'll be 1 and -2. Okay. So we want to do rise over run here. Well, that's the difference in our y coordinates, so 3 minus -2, over the difference in our x coordinates, so that's 2 minus 1. So that's 5 over 1. So m is equal to 5. And let's just double check. Well, if we'd done our slope first, we would have narrowed it down to b and e. Okay? But now we know for certain that y equals 5x minus 7 is going to be the equation that we want completely. So 5x minus 7, that is the equation we want. And that is E. Now if we wanted to, we could do a check. As I try and occasionally mention, you should do your checks when you can. I want to check that every one of my midpoints satisfies this. So I want to know that no matter what value of P I put in, I should get my y coordinate is equal to 5 times my x coordinate minus 7. So let's work this out and make sure it all works out. So 5 times p, it's going to be 5p plus 15 over 2, and we'll change this 7 into a 14 over 2, so we can combine these two fractions. All over 2. And wouldn't you know it, we do have both sides are equal. Okay, so we did a little double check, and every one of these midpoints satisfies this line. So we do know we definitely have the right answer. So that does it for the B part on the Fermat, the 2001 Fermat. Stay tuned for the questions 21, 22, so the C part, the last 5 questions. And if you're liking the contest so far, feel free to throw a like on the video and subscribe to keep up to date with all the other videos I'm going to be posting. Part C will be up soon, if it's not up already. And yeah, that's about it. So thanks for watching, and I'll see you guys in the next video.